Hello students, Stride here again. Today start chapter 14 notes. Chapter 14 titled Mixtures and Solutions. Section titles will be types of mixtures, solution concentration, factors affecting solvation, and colligative properties of solutions. Section 1. Objectives, you're going to need to know, be able to compare properties of suspensions, colloids, and solutions. You're going to need to understand these. You're going to have different types of colloids and solutions. You need to be able to identify them, and then we're going to look a little bit at electrostatic forces involved in colloids. Our main idea is mixtures can be heterogeneous or homogeneous. Old review vocab. A solute is a substance dissolved in solution. Got quite a bit of new vocab we'll get as we move through this section. Anyway, start with heterogeneous mixtures. Heterogeneous mixture does not have a uniform composition, and individual substances remain distinct. One type of heterogeneous mixture is a suspension, and a suspension will settle out if left undisturbed. Suspensions can be separated by filtering, so some examples: muddy water, clays, and clays. Colloids, another type of heterogeneous mixture. They're intermediate sized particles, about 1 nanometer to 1,000 nanometers. They do not settle out, nor can they be filtered. Main examples of colloid: milk, and colloids can be classified according to the phases of their particle, and the most abundant substance is called the dispersion medium. So some various types of colloids listed here in 14.1, so you'll want to add this to your notes. Just a lot of different types of colloids, depending on what is dispersed and what is the dispersing medium. Brownian motion is rapid, jerky movement of particles in a liquid colloid from the result of particle collision. Such as so particles collide, they move around in a rather random fashion. That's called Brownian motion. Tyndall effect, scattering light by dispersed colloid particles. You see this effect if you're driving in fog at night with your lights on, and you click your brights on. Light scatters a lot, and the light spreads out. When you're on your low beams, it usually stays under the fog and doesn't spread out as much. But fog is a type of a colloid. Solutions, though, are homogeneous mixtures. We're starting a little bit about homogeneous, and we have two parts to them called the solute and the solvent. Most solutions we deal with are liquids, but we do have gaseous and solid solutions. In this course, we don't deal too much with gaseous or solid solutions other than talk about them. We work a lot with liquid solutions, though. And here's some various types of solutions. Again, another thing to add to your notes. So we can have gas solutions, liquid solutions, or solid solutions based on what the solvent is. Typically, we think solvent, it's the substance that's there in more abundance, or what you're dissolving it into. Solute, substance that's in has less of this substance. And you can have air or gases dissolved in gases, such as air. You can have gases dissolved in liquids. We get a carbonated water, so a lot of different kinds of solutions. So when we say something will dissolve another thing, we talk about it being soluble. If we're dealing with liquids that will dissolve in liquids, we talk about miscible. So miscible is just a special type of soluble, and then we have insoluble, something that won't dissolve or dissolves at such a small rate. We consider it insoluble. And then liquids, again, to liquids that will not mix or dissolve, we call immiscible. So, miscible substances are, just definition we just had, and it's circled there and stated, two liquids that are soluble in each other. Two liquids that are not soluble in each other, A would have been immiscible. Solids that dissolve in liquids, that could be a description of a solute, or soluble, either would work, and this one's more referring to insoluble, but miscible always refers to liquids. And the jerky random movement of particles in a, well, and that's another definition you should know, Brownian motion. Tyndall effect refers to scattering, Charles' law, kinetic energy, not particularly related to this concept. Oh, that completes our 14.1 notes. That's it for now. Till next time, strike.